Students, welcome to Sourav's classes. This is IIT JAM Mathematics 2021 solution, and in this video I'll be solving from 26. So this says that f of 0, 1, 0, 1 be a non-constant continuous function such that f of f is f. Define this E of f. So this we need to talk about the openness and closeness of the structure. So f of 0 to 1 is giving you 0 to 1. So here it is f is non-constant, f of f is f, and E of f is this. So let fx equal to x. So f of 0 comma 1 is 0 comma 1. Okay, so 0 f of x, 0 f of x is f of x. So f of f is f. So this thing can be written as 0 to 1, f of 0 to 1, and that is equal to 0 to 1. So EF is actually an interval. B is the correct answer. Next, let G be an element of S7 such that G commutes with the element of 2, 4, 6, 3. So how many such number of G's are there? Okay. So S7 and 2, 6, 4, 3. So this is 0 n of S7 Ci of f. So this is number 1. O Ci of f is the number of elements having same cycle decomposition of f. So number of elements having same cycle decomposition of f. So 7 factorial 1 cube 4 to the power 1 3. 7 factorial by 24. So now in this way 1 2 3 4 5 6 dot 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 3 factorial 7 c4. So 7 factorial 3 factorial 4 factorial 3 factorial 7 by 3 factorial. So this is 2. So from 1 and 2 we get S7 Ci of f. So 7 factorial by 4. So this thing is 24. Just redrawing it. 7 factorial by 4 factorial. So answer to this question is 24. Next, let G be a finite abelian group of odd order. So we can take G equal to 2k plus 1. Consider the following two statements. The map of the G f to G is defined by f of G square is a group isomorphism, and pi of this G of is E. So which one of them are true, or both of them are true? So this is in the Ken abelian. So f of G can be written as G. So f of G is equal to G square. So we have f of AB is AB whole square is AB or AABB or A square B square, that is equal to FA dot FB. Again with respect to kernel, f G belongs to G given f of G if G belongs to G square equal to E G. So order of G equal to 2 equal to G belongs to G. O of G equal to 1 comma 2, and that is E. So hence it's an isomorphism. Statement 1 is correct. Next, so pi of g belongs to g of g equal to e does not belong to any element of order 2. So g1, g2, dot 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 g of 2k plus 1 is also e. So g1, g2 into g2 inverse, g3 into g3 inverse. In that way, gk into gk inverse is also e. So statement 2 is also correct. So both of the statements are true. Option A is the right answer. 29. Let n greater than equal to 2 be an integer. Let a of c of n is a linear transformation defined by a of z1, z2, zn is z1, zn and z of n minus 1. So which of the following statement is true for every n greater than equal to 2? So a to cn is defined, this first transformation, as a of z1, z2, zn is zn, z1, zn minus 1. So we can say that sigma equal to 1 n minus 1 dot 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 3 2. So let this 0 0 dot 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 1 1 0 dot 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 0 0 1 dot 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 0 0 0 and all these things 0 0 0. So this is the orthogonal matrix. So M equal to A of this, MMT equal to I. So 0 1 0 0 is here. So x square minus 0 plus of minus 1. So x square minus 1. So all eigenvalues of A are of modulus 1. Okay, so B is the correct answer.